it will seem a little backwards at first, but what you do is you start with this result. You start with the then part of this, okay? You start with this, with the epsilon in here, and it's going to help you pick a particular delta. And this is the basic flow for every one of these problems we're going to show, all right? So my f of x is x plus 1. So I have x plus 1 minus 3. All right, there's the function, minus 3. And I'm going to write less than epsilon. Now, this is the result we want to get to, which is not the way you start a proof. You never start with the result. That's stupid, right? But this is what we're going to call our initial work. This is simply going to guide us to find the proper delta to start the proof with. Okay? That's what we're going to do. Initial work, I'm going to forget. To find the proper delta, where delta is a function of epsilon, meaning it's dependent. I'm just saying it's dependent. The delta you pick is dependent upon epsilon almost every single time. This is our initial work to find the proper delta so that we can start the proof. To start the formal proof. And this is just initial work. This is not the proof itself. Okay? All right. Over here, this part of the proof, right? 0 less than x minus a less than delta. In our case, the a would be the number 2, right? A is the number 2. Right? As x approaches a, x minus a. So 2 is our a. Yeah. That's just a guide, right? Just keep that in your eyesight. That's all you need right now. So you have this expression you want to manipulate, and you have this expression that you want to get to. You want to get to the absolute value of x minus 2 over here, okay? And when you've done that, you will know what your delta is supposed to be. Okay?
And so where did the x minus 2 come from?
This part, you're saying, we see this is part of the proof. I have to start with this and get to this.
Yeah.
So this part, the a, is always whatever x is heading towards.
Oh, okay.
So x minus 2 less than delta. The goal is to find delta. Find delta. I just want this before you. I want you to see this so that as we manipulate this a little bit, you're going to match it up with this. Okay? This one's going to happen pretty fast. So the first thing you might do is say x plus 1 minus 3 is x minus 2. X minus 2 less than epsilon. Wait a second. That's exactly what that says. That says epsilon value x minus 2. So now what do you think delta should be? Comparing this and that, what do you think delta should be?
Less than 2.
Now don't give me a specific number. It must be dependent upon epsilon.
Less than 2.
It's epsilon itself. Delta should be epsilon. Or do you think smaller? And that's what we just saw in our 2 examples. When we chose 1, we chose 1/2. We chose 1 for epsilon. What was delta? 1.
That's
right?
That's because the function is x plus 1, right? Reason.
No, well, because of the slope. That's because of that 1.
Yeah, because
That's true. Yeah.
in certain.
And that's what Carrie asked. Carrie said, does it always work out that the epsilon and delta are the same thing? And I said, no. Except it's unique to this problem. So you see, even through the workings of the proof, that when you're matching up this side with this side to see what delta should be, it is epsilon. In this case, delta should be chosen to be epsilon itself. So whatever number you give me, if you give me 0.01, right? The function is going to be 0.01 away from 3. Then I'm going to pick delta to be 0.01. X must be 0.01 away from 2. If you throw at me any number, I'm going to give you the same number back. Whatever you give me for epsilon, I'm going to give you the same thing for delta. It's going to guarantee the distance between the function and 3. Okay? So now that we see that epsilon should be chosen, the delta should be chosen to be epsilon itself because we are comparing the latter part of the proof with the former part of the proof, we can now proceed to prove what we want. Okay? Remember, this was just the initial work to see what delta should be chosen as. And we see delta is a function of epsilon, right? They are the same in this case. Delta is dependent upon epsilon. So now you start the proof like this. You write out this mumbo jumbo here, right? Write out that. So that and 0 less than x minus 2 less than what? epsilon. I'm choosing delta, right? If for all epsilon is greater than 0, there exists a delta greater than 0. And I'm going to pick, in this case, that delta is epsilon. Then, as long as 0 less than absolute value of x minus 2 less than epsilon, that is, the distance between x and 2 is less than epsilon, then I can manipulate this and I go back up this chain. This is the simplest problem possible, by the way. All right. I go back up this chain, so I can separate this out and I can write this as this then implies that x minus plus 1 minus 3 is also less than epsilon. All right? Which is how we want to show. As long as this is true, it forces this to be true. So therefore, the limit is 3.
Wait, what did you do in that last step?
I merely undid, and that's why you guys aren't going to like this very much if you don't like it, or if you don't like it enough already. All you do is move back up this initial work you did. Okay, so you have to start with it's an if-then statement. So if-then means I got to start with this and end with this. This has to imply this. So if I start with this, x minus 2 less than epsilon, because I'm choosing delta to be epsilon in this case from the initial work we did, it seems like delta should be epsilon.
Delta.
Say again?
And so you chose epsilon to be delta?
In this case.
Okay.
Delta and epsilon happen to be the same in this case. It's a very simple case. So as long as I choose that to be true, then that will imply the next step is just going back up this, right? I'm breaking up x minus 2 into x plus 1 minus 3. That is, right, function minus the supposed limit is also less than epsilon. That's what I need to show. Yep.
So is every time that the slope is 1, is epsilon going to be the same thing as delta?
Yep. That's right. Let's change the slope.
Wait, hold
Or
on.
let's do a
Why was
different
the
function.
limit 3?
I think you'll get the idea better if we just do
Wait,
another
never
one.
mind.
What's that?
Never mind.
Tell me, Cornelia, what?
No, I said so the limit is 3, and up there it says the limit is 3.
Yeah, but we didn't know. We're trying to prove this. We're proving this.
I would prove
This
it.
is not for certain yet. We're making sure it's true by using the definition of limit.
Okay.
We just proved that it is 3.
Can you put the next one up and can we like start it and then like check with you?
Yeah,
Like
if you want. Roger, you have a question?
Yeah, so the proof is the ending is the top, right?
The proof is,
Yeah,
if you can get from here to here.
Now, I know what you're solving the problem.
Yeah.
That would be your ending part, right? That would be.
Yes. You start with this.
Just eat it from him.
Now your delta is whatever you happen to choose. In this case, it's an epsilon. It could be 5 epsilon, it could be epsilon 5, it could be all sorts of different things, right? It has epsilon in it. And then you work from that down to this statement, right? You've got to work down to your function minus the supposed limit is less than epsilon. It has to read that at the end. Your function minus the supposed limit less than epsilon, and that means it is the limit.
The function can't be 3 because it would equal 0, right? Function f of x is minus 3.
That's why epsilon is always greater than 0.
Yeah, and that, so if the limit is at 0 because it's approaching 3 whenever it should get there.
Yeah, that's true. Yeah. Matter of fact, that's the reason for this, right?
Yeah,
This is saying the distance between x and a is always greater than 0. X will never be a.
Yeah, it's like, for me, it's just easier to understand that way. It's like, the way it's set up, to me, it looks like the 3 is there. Like, the reason why the limit is 3 and the way the problem sets it up